Hello everyone, this is Skynet Terminator's team, and today we are here to talk about how to determine the housing sale prices in New York City with the help of predictive models, which means a model that will predict the sale value of a house in future. Meeting the team, I am Soman Demla, and along with me we also have Soumya Batra, Aisha Gupta, and Nikhil Vishwanath. Going through the project overview, first we understood the background of the business and studied about the data, and then went through the different phases of the project, which includes data preprocessing activities such as data cleaning and transformation, and then building our models on that data and performing the model evaluation on certain metrics, and then choosing our champion model on the basis of those metrics. Finally, concluding our analysis with the model implementation. Talking about the background, as you know, that purchasing a house is one of the biggest investment decisions that an individual has to make. And as true many Indians, we will probably buy a house before beginning a family. That's why this subject is quite close to our hearts. And thereby, we will be predicting the housing sale prices in New York City, which is also called the City of Dreams. The New York City is composed of five boroughs, which are Bronx, Brooklyn, Manhattan, Queens, and the Staten Island. As you can see, the average rent of each borough is shown here. Also, in each of these boroughs, the neighborhoods such as Soho, Tribeca, and Midtown Manhattan today cost around $1,376, which is quite a number. And these housing prices or property prices are mainly determined based on the neighborhood, the type of building, and the square feet area. Talking about the scope of our project will include the goals, the business problem, and the target audience. Our goal is to understand the factors that determine the sale price of a property, and business problem is to explore and analyze this data and predict models on it, and then on the basis of those model results we will be helping the target audience. In this case, the target audience will be all the prospective buyers and sellers of the New York City housing. So now I will hand over to my teammate Soumya to talk about data description and analysis part.
Thank you, Sumit. Now, let's talk about the data. So, the data is from the New York Department of Finance and is the property sales data for 2019. The combined data set includes 20 columns and 81,509 rows. The data set includes information about the sales price, which will act as a target variable. Then we have information about the number of units. Then we have information about the area of the apartment, both the land square feet as well as the gross square feet. Then we have information about where the apartment lies among the five boroughs and where does it lie, in which neighborhood does it lie within each borough. Further, we have information about the building class category, the tax class, block, and the lot. And then we have information about the year it was built in and the sale date. Now we did some exploratory data analysis. So as you can see, the distribution of the properties in the New York boroughs, most number of apartments are in Queens, followed by Brooklyn, Manhattan, Bronx, and then Staten Island. Then we have the distribution of the properties based on their tax classes. Most of the apartments are classified either as tax class 2 or tax class 1. There are few apartments which are classified as tax class 4. Now, these are the six interval variables that we would like to focus for the purpose of our analysis. As you notice that there are high skewness and kurtosis among the variables. So for the purpose of analysis, we would be doing some transformation to reduce that. Now the next point of focus over here is the zero minimum value for the sales price and no missing value. You may be surprised that why is the sales price zero? Now there is a logical explanation for that. The explanation provided by the data provider is that these are the apartments which changed ownership without any exchange of currency, or these apartments were put up for listing but could not be sold and they do not have any registered user. So for purpose of analysis, we are not going to use these records. Now let's talk about some data processing. So first, the data access. So the was accessed from the New York City Department of Finance. We used our Selenium package to get the data from them. Once we had the data, there were five Excel files. These five Excel files were consolidated into one single dataset using the Pandas package in Python. The combined dataset includes 20,000, 80,000 records and 20 columns. And we performed few data exploratory analysis, which was discussed in the previous slide. Now, based on the results from the exploratory analysis, we decided to do some data cleaning and data transformation. So the data cleaning includes outlier removal for the interval variable outside the 3 standard deviation range. And then the imputation includes mean imputation for the interval variable and mode imputation for the class variable. And finally, we did transformation to reach normality using the log transformation method. Now I'd like to hand it over to Ayush to discuss about the data processing in details. Thank you.
Thanks, Soumya, for giving us some insights about the data. Now, let's talk a bit more about how data was accessed and what were the kind of transformations done to the data to get the final data prepared for the modeling. So, the very first thing, how the data was accessed. So, we got the data from Department of Finance website of New York City, and it was named as rolling sales data, containing information about various basic details. In total, there were 20 different variables in the dataset, and the data was for last 12 months for all tax classes, sorted by different borrows and done by blocks. Now, to get a wholesome dataset, the next thing we did was to combine the data that we got for five different boroughs of New York City into a bigger dataset. The different boroughs were Bronx, Queens, Manhattan, Brooklyn, and Staten Island. The overall dataset that we got after merging all the datasets contained nearly 81,500 rows and 20 columns. In the later stage, data was transformed and cleaned up. So, the very first thing that we did was to remove outliers. Anything above and beyond 3 standard deviations from the mean was considered to be an outlier and was removed from the data. So, for commercial units, anything above 85 turned out to be an outlier and was removed. For gross square feet, anything above 894,000 was removed. For land square feet, anything above 1,985,040 was removed. For residential units and total units, anything above 1,000 was removed. And for sale price, anything above $216 million was removed. And also there were some values that contained missing values. Those were also removed. Those records were also removed. For transforming the variables, two basic transformation techniques were used. First was log transformation, and the second one was square transformation. For all the variables other than tax class at time of sale and total units, log transformation was used, and only for these two variables, the square transformation was used. All the variables but sale price, which was our target variable, were imputed with the help of mean imputation method to remove all the missing values. Now, a thought was given to data reduction processes, and two different data reduction processes were approached or were used to see if they would work for our for our modeling methods or not, or I should say for data preparation methods or not. First one was using principal component analysis. It was done on our dataset, and the results of PCA suggested three different principal components that should be created. But the PCA result was not used, as bringing down variables from 20 to 3 would have killed our explanatory power of our analysis or of our model. So we did not use PCA. Then cluster analysis technique was used, and within cluster sum of squares was calculated. And with the help of elbow method, we found out that choosing three clusters should be a better approach. But the three clusters had some overlap between each other. And again, this technique did not turn out to be very effective for our analysis. So we did not use any of the data reduction methods. Now, I would like to pass it on to Nikhil for explaining the modeling that we did and the results.
Thank you, Ayushya. Let's now look at the various modeling techniques we have implemented to build our predictive model. The performance of a model is directly related to the type of data that is fed into the algorithm. Data that is not cleaned or has a skewed distribution with many outliers tends to reduce the performance and efficiency of certain models. So from the previous slides, we have seen the various stages through which our data has passed, and the data is now ready for further analysis. So we started off by doing a validation and training split. So we used a 70-30 training and validation split where 70% of the data was used to train the model and 30% was used to validate the performance of the model. Since we had close to 81,000 records, 30% of the data was a considerable amount to look at the various parameters and performance of the model. So after splitting the data, we looked at the various models that could be used in this case. Since our dependent variable or our target variable is an interval variable in terms of the sales price, we used a regression, a decision tree, and neural network model. These three models have their own characteristics and come with their own pros and cons. So, a decision tree is a rule based algorithm, and we use this decision tree to understand the variable importance. So, variable importance in a decision tree is mainly about how much a given model uses a particular variable to make accurate predictions. So, on this slide, you can see that the gross square feet and the land square feet were some of the most important interval variables, followed by the number of commercial units, total units, and the residential units. In terms of boroughs, New York is divided into five different boroughs, as you can see on the left side. And Manhattan was the most important borough. And this is not a surprise, considering neighborhoods like Soho, Tribeca, and Chelsea, which all belong to the Manhattan borough and are some of the most expensive real estate listings in New York. So once we have built our model, we need some metrics to assess the performance of our model. So we looked at the root mean square and the R square as our evaluation metrics. So the root mean square is basically the difference between the predicted results and the observed values, and a lower RMSE or a root mean square means a model is performing better. In terms of the R square is basically the proportion of variance in the dependent variable that is being explained by various independent variables. So we looked at these metrics for all the three models, and neural network turned out to be our champion model. So the neural net had a RMSE of 0.748 and a R square of 43%, which was the highest among all the models. But the neural network has its own sets of strengths and weaknesses. The biggest strength of a neural net model is its complexity, but it can also be used for very large data sets. The advantage is that it can easily be adjusted to make the model more complex by adding more number of nodes and hidden layers. And the biggest weakness for a neural network is basically it's a black box model. So it uses a very complex algorithm. It uses a backpropagation and various optimization techniques to understand how the model is performing. And the results from this model can sometimes be difficult to interpret. So I would like to conclude our presentation by summarizing everything that we did in this project. We started off by scraping data from the Ministry of Finance New York website, which is a publicly accessible website and contains the sales information for all the properties listed in New York. Once we had the data, we went on to perform various data processing measures. So we started off with a imputation, and we did a mode based imputation for our categorical or class variables and a mean based imputation for our interval variables. Next was the transformation stage, where we performed a log transformation to ensure that the variables have a distribution as close to normal. Outlier removal was the next stage, where we removed certain records which were 3 standard deviations away from the mean. After all our data pre-processing, we went on to perform our predictive modeling. So we started off with a 70-30 validation and training split, and then we created three different models: the linear regression, decision trees, and neural net. and the neural network was selected as our champion model. So, our biggest takeaways from this project in terms of learning was to understand how real life data is not always perfect for modeling, and it takes various stages before data can be used to build various predictive models that can help improve the way we make decisions. Thank you.